Up to permutations, and a permutation is an arrangement of objects in a particular order. For example, these are all the permutations of the letters CAR. So we got CAR, CRA, RAC, RCA, ARC, and ACR. And if you think about it logically, it just right now we've got three different ways with C at the beginning, then R at the beginning, and then A at the beginning. So that's the three here, using the counting principle. And then when we have the C at the beginning, we only have two possibilities left. We have A or R as the second one. So that's the second part of the counting principle, so times 2. And then the final one, well, if I have the C and the A down, then the last one has to be R. And this works the same way for each of these. So if you're trying to figure out all the possibilities, you can just multiply the total number by there. So if you look here for this as an example, find the number of permutations of the letters G-O-V-E-R-N. I can make an organized list like this, but even when I made the organized list, I nearly went ahead and doubled up a couple and made a mistake there because I knew there were 6, but I nearly went ahead and came up with 2 that were exactly the same. So you do need to be careful about that. So the easiest way of doing that is just by counting them up. So we got 1, 2, 3, 4, 5, 6 letters. And so because there's 6 letters, well, there has to be. So if you look here, it's just going to be, well, 6. There's 6 letters. So 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720 different ways. Now, again, that sort of makes sense because when you have this letter here, any letter could be at the beginning. It could be G-O-V-E-R or N, so you get a bunch of different possibilities of doing this. Now, one way of talking about this is through the term that's called factorials. Now, factorials is just the representative of the product of all positive integers less than or equal to a number. Now, make sure that makes sense. 0 is obviously not a positive number. It's a neutral number. And the way to represent the factorial is by using an exclamation point after a number, like this. 5 with that exclamation point is a factorial. That would just be 5 times 4 times 3 times 2 times 1. And that would be 120, I believe. So, and if you look here, this is something where, an example of where you might use this, if Dorian wants to order 5 different types of ice cream: vanilla, chocolate, strawberry, mint chocolate chip, and rocky road in a cone. It would take a very long time to figure out all the possibilities of doing that, which one you'd start off with, because the flavors might meld together differently, and so all the possibilities of doing that. So all you do is you count up the amount of ice cream types: 1, 2, 3, 4, 5. So there's 5 different flavors. So in that case here, what's going to happen is we're just going to figure it out the factorial way. And so again, this would be the 5 flavors that could be at the bottom next to the cone, and then there'd be 4 choices after that, and then 3 after that, and so on. So you'd have 120 possible ways of putting these 5 ice creams in a different order. Now, there's a big difference between finding permutations when you only need to find part of the order. Then you just need to figure out how many items you need to put in order, and I'll give you an example of that in a second. So if you're figuring out the number of 2-letter permutations for the following letters, it's A, B, C, and D. So you're trying to figure out 2-letter permutations. And all you're going to multiply is, you're just going to multiply 4 times 3, which is 12, because there's 4 possible ones for the first one and 3 possible ones for the second one, and you don't care about the remaining ones, what the order the other ones are in. So there's 12 possibilities. Now, in the previous problem, if Dorian can only get 2 scoops of the ice cream and there are 5 flavors, then what are you going to have to do? You're going to have to figure out a different way of writing it down. Instead of it being the 5 times 4 times 3 times 2 times 1, we just care about the first 2, so it would be like this.